Hello everyone, welcome back to the new video. Hope you all are doing well, and in this video we are going to explore a tool. Basically, we're going to see how we can automate web cache reception vulnerabilities. This is actually my favorite vulnerability, like after broken access controls, but I find it really fun because it's not very difficult to find and the impact can range from medium to high, so it's a really good one even if you're a beginner. So I was actually looking for different kind of tools for web cache deception, and the first one I found was the burp extension, but that extension is for professional only and not a lot of people have the professional burp suite, so that's why I came across another tool. So here it is. You can find it in the official Kali Linux page and you can download it through sudo apt install command. It's called Web Cache Vulnerability Scanner, in short, WCVS. Okay, so here is the help. It is created by HackmanIt. So it was available here as well. This is the official GitHub repo. You can check out the source code if you're interested. But you can just simply download this whole thing from here as well and here as well using Go. But I find this one much easier. I'm using Kali Linux in WSO, so it was pretty easy for me to install. So if I type WSVS, right? No, it's WCVS. Okay. So I haven't provided any command, that's why I'm getting it. But if I just say -h, I can get the whole commands and different kind of parameters that are available. Anyways, so once you have installed it and you have it here, we are going to test this tool out. I'm not going to like promoting this or something. I'm just checking if this tool actually works or not. Because I have created a whole playlist on web cache reception and I have walked through this vulnerability like step by step, talked about delimiters, what are cache busters, what is path normalization in origin server or cache server and everything. So you can check out the playlist from the I button if you don't know what cache deception is. But if you know and you have followed through that already and you want to speed things up, you understand things work, now you just want to automate it while bug bounties or pen testing, this is the perfect video for you. Okay, so let's not waste any more time and let's test this out. Okay, so I have web cache deception labs here, as you can see, and I'm going to test each lab one by one and see how this tool works. So over here we have the first lab. This one is pretty easy one. Okay, so now we have the lab loading over here. Now let's understand, let's look at the help command. Okay, so V is for verbosity. You know what, this tool actually has a lot of like extra things that you can try. You can also try smuggling and other things, but I'll be focusing only on web cache deception. So I'll only tell you the necessary parameters that you need to know. And as you can see, we have a cache buster CB and we can set cookies with SC commands. So these are the commands that are actually necessary for us. You can set a header, you can set a query parameter. These are the ones that are important. If you want to send a post request instead of get, then you have to provide a particular post and then you have to provide the values as well. Now the thing is, in case of web cache deception, we are supposed to send a get request because in web cache deception, our main goal is to cache a page that contains some sensitive information. Could be API key, could be email, some file leak, I don't know, could be anything, but that is very sensitive and we want to cache it. Because if we cache it, anyone can see it. So by simply sending a get request, it will cache the response and then anyone can see the response that contains the sensitive information for that particular user. Okay, so you can also provide some word list. I don't think we're going to be using that right now, but okay, so we have the lab here. Let's go to my account. Weiner Peter. Okay, now you can see we have the API key. I want to show you the response. So I have my burp here. I'm going to turn on intercept. Okay, so I'm keeping these tabs side by side so you can understand how it's working. So I'm going to copy the URL, set the scope here, remove this and add. Cool. Now let's turn on intercept. Reload the page and we got the request. Now let's send this request to repeater, turn this off. Let me maximize it, send the request. So we are getting 200 worker response, and we are also seeing the API key in the response. And that's why I want to cache it, because this response contains a sensitive information. Okay. So we don't even know if this is getting cached or not because there are no caching headers, but we don't have to do any of that. We're just gonna automate it. Let's see how this tool works that out for us. Okay, here goes the command, and now we have to provide URL. Okay, here we go, URL to scan. And then let's copy it. I want to tell you that you cannot just give in like any website URL when you're testing for this. You have to give a specific URL, the URL that has a response that contains sensitive information. We are giving this URL because we know that my account path is giving back an API key. Okay, keep that in mind. Now the second thing we're going to do is set cookies, because that is important. So this is our cookie here. We're going to copy it. And it was SC, right? -SC. Yeah, here it is, set cookies. Okay, so -SC, and then in double quotes, we're gonna paste our session cookie. Now we're gonna tell what we are testing for. So over here, we have this option, only test. Choose which test to run. Use the comma separator to specify multiple ones. Example, only test deception, cookies, CSS, forwarding, smuggling, DOS, headers. As I told you, there's a lot of things in it, but we are covering deception. So we're just gonna copy deception, and we're gonna say -OT deception. Cool. So if you want to generate a report for this, you can do that as well using the -GC option. You want to create a log file for that. You can also do that using the GL option, but we are not going to do that. Let's say verbose. We want to look at the verbose output so we can understand what's going on. And we can set the verbosity. So I'm going to set it to 2. So I'm going to use this option as well, force. Perform the test no matter if there is a cache or even the cache buster worked or not. Okay, so I'm just gonna type that in as well. Okay, that's enough. Don't need anything more. Let's hit enter. Cool. Testing for web cache deception. Damn, it already found it. Xcache header was found. So we know that from the response, we didn't see the header, but somehow it was able to identify the header through some testing. We're going to look at that as well. So here we have the curl command, sending this curl command in the background, and this is the payload. The payload has .css. Okay, so there were multiple payloads it tried, and it seems like all of them worked because we have this green symbol. It means it's working. Otherwise, we don't see that. Cool, successfully finished the scan. Now let's copy one of the payload. Let's copy this one, non-existent one.css. Let's paste it. So the idea is if I paste it here and I'm still getting 200 response along with the API key over there, it means this is working. Okay, so I'm gonna send, and we're getting 200, and so we do see the API key as well. So notice one more thing, that Xcache says miss right now. So if we send this again, it says hit. It means that it is cached. To test it, if it's actually working or not, we're going to copy the URL. So let's open the private window. We're going to paste this URL. And we can see that the API key is cached. This whole page is cached. And we can see the API key revealed here as well. It means we just found the web cache deception vulnerability. That's amazing, but the difficulty of this lab was kind of simple, so we're gonna try out another lab. Okay, so I'm gonna close this one for now, and let's try out this one, exploiting path delimiters for web cache deception. This one is medium level. So I've talked about what are path delimiters in the video. where I covered this vulnerability, like manual testing and everything. So you can check that out from the I button right now if you want to. Let's access the lab. I'm gonna close these for now. So let's copy the new URL we got, and I'm gonna paste it over here, add it. Again, I'm gonna put it side by side, and I want to capture the request, but before that, let's log in. What the heck? Okay. Anyways, we are logged in. Okay, so now let's turn on intercept and capture the request. Let's send this repeater. And okay, we want the my account, not academy header. So let's type in my account. Okay, cool. So we're getting the response and we are getting the API key. Again, we have to cache this whole response using web cache deception. So what we're gonna do is we are just gonna copy the new URL and we're gonna change our command a little bit. So I'm just gonna remove this whole thing, paste it. And I want to mention you that don't put / here. If you put / here, this is not going to work out, because when web cache deception tests for delimiters or cache busters or anything, it does that by appending stuff like the CSS or JS, question mark, hash, I don't know, different kind of stuff. So if you want it to work out, just don't put a / here. It's gonna mess things up. Now we have to change the session as well. So I'm gonna remove this and gonna copy this session. I think I need more coffee for real. Anyways, let's hit enter. Okay, test has started. And why I think it's taking a little bit more time than usual. Okay, cool. Xcache header found. Hit. Damn. Before we check it out, I want to show you something, because if you remember the last time we used we used this payload, right? So I'm gonna copy it and try out this payload here. I just want to show you that this payload is not working for the second lab because this is much harder. So as you can see, it simply says 404 not found, but we do see a header. So this does give us a little bit of lead, but we still don't know how to cache it. So that's why this tool has found a different way to do it. It found it by using delimiters, which I think is kind of smart, because delimiters could be anything like question mark, hash, semicolon, stuff like that. So I've talked about it really in detail. I don't want to make this video long. That's why I'm mentioning it. Watch it if you don't know about it. So this is the payload that worked for us, :non-existent lavin.css. Obviously, it can be any name, ABC, XYZ, whatever. The main point here is this semicolon. This is the one that is actually triggering the caching mechanism here. So if I go here and remove this everything, notice that I removed the / here as well, and send the request. You can see we are getting 200 response, and we are also getting the API key along with the Xcache header. It says miss, but if you send it again, it says hit, means it is cached. So it could be anything, I'm just gonna remove this whole thing. Let's say medusa.css. Send it again, and yeah, it's working. Cool. So semicolon, it was able to identify is the delimiter here. Let's copy it and test it again in the incognito tab. Private window. Cool. Again, we can cache it. That's freaking great, man. This is saving a lot of my time, because if you are one of those who have watched my playlist, you know how much time it actually took to find the actual delimiter, because I was going through each delimiter one by one, and damn. I don't know what you call it, delimiter or delimiter. Anyways. So this is working again, but now we're gonna do a hard lab. I really like the labs of Sugar because in real case scenarios, you will find cases like this as well because I've seen people finding bugs like these and these as well. But it has some crazy level labs as well, which is rare. But I like how they're putting it here so anyone can practice it as well. Okay, guys, we're gonna try the expert one. This is gonna be crazy. So this is our last test. Let's see how it goes. Okay, I don't know why it took so much time, but finally we are in. I always get confused. It's like Wiener or Wiener. Cool. Okay, we are in, but we don't see anything this time. And that's why this is hard level. But don't trust the UI, guys. Don't trust it. Because let me show you something. Okay, we're getting the response. We can see the server is Apache Coyote 1.1. And what do we have here? We have a hidden CSRF token. So this time we don't have API key, we have a CSRF token and it is not visible. It's in the HTML. But this is sensitive because if you get a CSRF token, you can perform actions on any other user behalf, right? We can perform CSRF attack. So in this case, we are simply chaining web cache reception and CSRF attack. If you're able to exploit web cache reception, you can perform CSRF attack, and that's a crit vulnerability actually, because you can then simply change the user passwords or whatever you want. But for this video, we are just going to cache the CSRF token. If you wanna know how to chain these two attacks, again, check out the video from the I button. Anyway, so we're gonna copy this URL and we're gonna feed it to the tool. Okay, my bad. Cool. Again, no / at the end of the URL, and we're gonna change the session as well. So we're gonna copy this value and we are going to paste it and we're gonna hit enter. By the way, guys, check out my LinkedIn page because Medusa is finally an official brand, so don't forget to check it out. Cool, it's trying multiple things, we can see, because we did verbose, that's why we are seeing all the attempts here, but nothing is working yet. You can see these are complex encoded payloads, and damn, okay, it wasn't able to identify it, damn. Xcache or cache hit miss header was found. No cache header was found. Interesting. Now we know the limit of the tools, guys. That's what I say. Don't rely entirely on tools. This is crazy. So this didn't work. So what works in this case? To save your time, I'm just gonna show you the solution, guys. So there is a whole process to it, of course, but this video can be too long because this video was about testing tool. So I'm just going to show you the final payload that actually worked in this case. As you can see, even the solution is so huge, and the main exploit was to perform a change email task. But over here you can see this is how the exploit looks like. We're using semicolon, a delimiter, and then we are using encoded /, and then a path like robot.txt, then another delimiter, and then a random value. Now, as much as I remember, I think we are using robots.txt here because the server only allows some valid file. Like if I go here and type robots.txt, we can see that robot.txt exists here, and so the server doesn't take any random file. But if you put in a legit file that actually exists on the server, it will take it and it will accept it, and then it will cache it as well. But it has to be in a specific format. Again, I think we're using delimiter because the server is using Apache Coyote, which it is using in the previous case as well. So yeah, again, there are multiple things, and if you really are interested in it, please watch the video from the I button. So that's it for this video. It was really fun testing this tool, and I think in the majority of the cases this will really work. But in cases where you want to try things like in expert level cases, you can do a little bit of manual analysis as well, and that is totally fine because this is doing the tedious task for us. So yeah, let me know your thoughts in the comments section, and don't forget to like and subscribe. So I'll see you in the next one.